Ricky, don't lose that number. For all you Steely Dan fans out there. Cellular intrusion detection. What does this mean? Well, this is the detection of cellular modules that remain static in a local area for a long time. How do we achieve this? We observe these hidden cellular devices must reveal their location when they transmit. Why do we care? Minor malicious devices such as credit card skimmers use wireless modules to transmit data back to the criminal who set them there. The most attractive option for these wireless modules being cellular modules. Why? Because they work anywhere where there's a signal. And while all message payloads are encrypted, the phone identifiers themselves are sent in plain text. But we'll get to that later. Now our solution, we're going to be monitoring all uplink channels of GSM cellular towers to gather information on who's transmitting in our area. The challenge here is how I'd isolate devices of suspicion from normal cell phones. So we think about what makes them different. And the three main behaviors I want to hit. The first being consistent traffic across several consecutive days. The second being consistent message power levels that we see from our receiver. And the third being timing patterns, whether location updates or pre-programmed behavior, such as sending an SMS every day at 5 p.m. And down here we have a small diagram of a gas station where one of the pumps has a credit card skimmer with a cellular module in there. Meanwhile, you have all of these normal cell phones coming in and out with customers. So our approach, we're using an SDR, or software-defined radio, to receive all of our GSM signals. And first we're going to scan all possible GSM frequencies to find the strongest signal, and then connect to that signal. Next, we're going to collect all the uplink messages of interest. We're going to save that to a database. Meanwhile, we're going to be analyzing this database for noteworthy activity, namely the three main behaviors I mentioned earlier. And back to those identifiers I talked about, there are two main ones, being an IMSI and a TIMSI. Your IMSI is a permanent identifier for your SIM card. A TIMSI being a temporary version of this. This is how the phone identifies itself to the network. So this is how we're going to group messages together to attribute them to certain devices. Now, two experiments. The first being, we're going to be comparing the variability of two different devices, namely on power levels. The first device is our test device, which is an embedded device kept in the exact same spot all day. And you're seeing a straight flat line because every message we're getting from that device is at the exact same power level of negative 31 dBm. Meanwhile, a mobile device that we saw in our area got close to our receiver and then very far away, and you can see this huge variability there. Now, our second one provides another metric of just the amount of traffic per TIMSI. So we're seeing about 77 different TIMSIs here. And we see that most TIMSIs show less than 20 messages. However, we have a few outliers here that have over 100 messages that can be attributed to our test devices. Now, our experiments prove that our approach can isolate suspicious devices from normal network traffic.